Hope my screen is visible, right? Let's get started. So on this session 3, we are going to cover about most of these, whoever familiar on the PL300 related Power BI topics, those related topics only. So adding the measures to the semantic model, in which scenarios you're going to create the measures, design scalable semantic model, like as per the performance tuning part, how we are going to get it optimize the model, those topics we are going to discuss. Along with that, manage Power BI assets and model security enhancements like row level security related topics we are going to discuss at the time. Fine. Add measures to the Power BI semantic models. Let's get start with this. So whoever still have a confusion on what is DAX and which scenarios we are going to use it, where these DAX objects are visible to you. So if you already open your Power BI desktop applications, there is a model tab right at the top ribbon level. There you can find out DAX related objects like new measure, quick measure, new column, new table. DAX stands for data analysis expression. So most of the functions are, whoever familiar with the Excel files, Excel related formulas, the similar kind of functions and operators, constant values you are going to observe on the DAX related ecosystems. And majorly, you have to keep in mind how we are going to create measures and which scenarios you're going to create the measures and the differences between a calculated column and a table and measure. These things we have to keep in mind. And the right hand side, if you're observing the icons, right, if you're calculating some business related requirement using the aggregation functions or textual functions, or maybe if you're using some time intelligence functions, always it's better and sustainable to make use of new measure or calculated measure. Quick measure is something like already the by default, the backend formulas have been derived. You have to choose the logic, or else you have to choose which business derivable you are going to create it. So in such kind of a scenario, you can choose that particular category. You have to drag and drop the specific parameters on the quick measure part. Automatically, the backend logic will be getting derived from your, and for the views. It's ready for the view. So you just have to simply drag and drop those quick measures and proceed as per the visualization that standards. New column is something we will call it as a calculated column as well, calculated column or new column. So if you are trying to take it as a reference of existing field and deriving some new columns, or maybe if you are trying to derive some specific logic like a conditions or some concatenation kind of an approaches, or derive something like advanced calculations by taking the reference. You have to make use of a reference. In such kind of a scenario, you are going to use new column. New table is acts like a bridge table. Sometimes we'll call it as a calculated table as well. So in such kind of a scenario, like if you are trying to generate some intermediate tables, you're going to use new table there. Fine. Let's move on to the measure creation. Defined with DAX formulas, if you're observing the calculator icon, aggregation functions as a set, whenever if you are preferring to use aggregation methodology like sum, average, min, max kind of a derivable, you have to make use of these measures only, defined measures. So there is a formula bar. You can find out this formula bar on all the views, report view or data view or table view or model views. There you are going to define these formulas. So maybe if you want to derive the profit related logic, it's related to the sales table. So if you're observing the logic, sales minus sales table cost. On both of the sides, we are using aggregation functions like a sum, or maybe if you are planning for average profit, you are going to use the average function. So whoever familiar with the Excel related formulas, there in such kind of a scenario, you can use this formula bar and try to derive these logics on this views by choosing the calculated measure or measure, new measure. So on the output value part, it is going to, on a fly, you are going to see their analysis or else visual on the reporting tab only, not on the data view. So on a fly, the values will be visible to you in the reporting layer, not on the table view, or it's not going to store it somewhere. The measures will be getting stored in the form of a cache. Please keep in mind that is very, very important. So as I said, not stored in a data model, it's going to stored in the form of a cache. And the output part, if you want to see the result of the measure, profit or maybe the total sales amount or cost amount and so on a fly, you have to simply drag and drop this particular exclusive measures onto your reporting tab so that you can view that analysis and then take proper decisions accordingly. If you have any questions, don't hesitate. So I'm just taking this session on behalf of someone who is not available, as I said. Fine. Understanding the filter context. This is very, very important. Still, there are a lot of conceptions, confusions related to it, which scenarios we have to use it, and how can we make this dynamic parameters or a filter context possible. So most of the time, if you are preferably using these filters based on some metric, we will use on the visual tab itself, the visualization filter tab, or if you want to get it filter based on by year or based on particular category or product item, example product item or categories related, you're going to use a calculated functions there. Calculate, and you have to supply the expression followed up with some specific parameters like a categorical information, which is getting filtered, so that dynamically the values will be getting filtered and you can see the results accordingly whenever you are simply drag and drop onto the visualizations part. One more example. So as I said, calculate. If you want to get it derived within filter context module wise, total sales for this particular exclusive for this 2015. This is how the values looks like. So calculate sum of is the function, which is an expression I'm passing there. And for the particular year of this particular order date 2015. Sometimes the better option is, instead of using the existing sales order table, if you have a specific date table, that is best approach. Okay, instead of using the existing columns, right? Existing column and sales order or fact related information. If you derive and make it as an table, date table, that is the best approach whenever if you're utilizing the time intelligence functions. Okay. There are three types of measures. How many of you are aware of this concept? Three types of measures: additive measures, semi-additive, non-additive measures. So if you are observing currently the semi-additive measures, results should be varies based on the dimension. And you are going to pass the semi-additive measures for calculation of the time intelligence functions on the averages, running totals, right? Average running totals or total calculation of the balances. In such kind of a scenario, you're going to use additive measures. I'll just try to give a brief about additive facts, semi-additive facts, non-additive facts, also, which I'm going to cover the next slides. Additive facts, which will be get support any type of aggregation functions, either it is in a sum or average or a distinct count, whatnot, everything, all the functions. Semi-additive measures are something which will be support few of the aggregation functions, not every time. Every aggregation functions like as listed, some average and so on. It supports few of the aggregation functions, not every another. Likewise, non-additive facts or non-additive measures too. So if you are trying to calculate percentages, ratios, and so on, in such kind of a scenario, you're going to make use of non-additive measures or non-additive facts. Make sure that when you are trying to use the filtrations part, the values, how it is working, okay, the output of the result, the derived result, it should be taken care. So you have to compare with the existing results when how the data is getting filtered on your reporting part. Okay, you have to validate, do some thorough testing, unit testing, basic testing by checking the backend data, which is available on your table chart, table view. Okay. As I said, if you're calculating or working on the time intelligence statistics part, time intelligence wise functions, if you're trying to derive, deriving a date table is the best option, because if you are deriving a separate date table for your projects, which we'll call it as a role play dimension, and even the conformant dimension tables part as well. You have to get it specifically, create the new columns like year, quarter, month. Maybe if you are trying to visualize it based on the physical year or weekend or weekday sales wise, or maybe if you are trying to perform time intelligence calculations and so on, deriving a separate table is as simple as easy. You can right click on the date table and mark it as a date table and choose the date field, which date field, whether we will definitely have a date field. The icon should be reflects in this way once you define it as a date table. Okay. And moreover, one more important thing that I just want to bring it over here. Whenever if you're adding the date related fields onto your canvas, reporting canvas, just try to check whether hierarchically it's defining with a year, quarter, month, and day level hierarchy. Hierarchy also matter. What I will do in the sense, personally, if you are trying to develop this project, we will turn off this auto feature, auto date and time feature most of the time. Okay, because it's a real-time projects, right? So we will not enable this feature whenever, right? Automatically deriving with the hierarchy of year, quarter, month, and date. We will turn off it. We will add the new columns by using calculated functionality. Suppose if I'm holding a date field on my date table. So if you are working on a time intelligence calculations, instead of using the existing fields, like as a showcase to here, year, how I'm deriving year of sales order table. I'm picking up from the sales order, existing fact related information, order date, and I'm filtering with the 2015. Instead of choosing this kind of an analysis, try to create a separate date table, make it as a make it as a date table there. Pick that column, date related field, which is holding the date timestamp or date format. And from there, you can define the new columns. That is the best approach. How the output looks like, if you're observing for the period of months from Jan to December, years from 14 to 2016, this is how the values looks like. Okay, each and every year. So instead of having a split of information in the hierarchy, each and every year wise, we can see that analysis. The backend part optimizations, it will be get tuned, and you can see the right views and reporting layer. And you can see on the right-hand side, some of the time intelligence functions regularly used, okay, period, previous month related functions. So you can see it, how we can compare it with the current year with the previous year. Okay, previous month as well. Likewise, there are, alternatively, we have a supplements like same period last year for the year-wise comparison, parallel period is there, parallel period year. And along with that, date add functions also will be helpful whenever if you are trying to derive based on, okay, calculations, how we are projecting. Either is a yearly wise for 1 year, last 2 year wise comparison, we have to pick it up, the right time intelligence functions. This is how we can easily identify if you're adding a new column. So on the top of it, so sometimes we'll get a query. Can we use the number related part, a new column, a calculated column? Yes, we can use it, excluding aggregating functions. Suppose total sales is equal to sum of sales quantity into sum of sales unit price, which is not a correct way of defining a calculated functionality. In such kind of a scenario, the best approach should be measure, explicit measure or calculated measure. So here we're just multiplying with the quantity into unit price. We are taking the existing fields like a quantity and unit price. We are deriving an output name called total price. We are not using any aggregator functions. And automatically, whenever you're deriving a new column or calculated column on a number related part, you can see a sigma symbol there, sigma icon, so that you can easily identify that is a calculated column related number field, total number. Likewise, if you're working on a categorical data or textual information, you can see the new column, okay, with the table symbol, calculated column with the categorical information, like if you're concatenating, or maybe examples I'm saying, concatenating with the two fields and deriving a new column, or maybe if you're deriving a condition based on the existing fields on the same table, in such kind of a scenario, the new column will be get added with an icon. Okay, and the values will be get stored on your data model. So that's the reason sometimes we will get a queries like, is that a best approach to create a calculated column, or can we derive the same logic at Power Query Editor? My recommendation is you can derive the new column at Power Query Editor if you need a best or very good performance at the refreshing part, and then performance related DAX related objects will be get it reduced. Okay, suggest you to derive a new column set Power Query Editor instead of it DAX related expressions using calculated column. Okay, because it has to refresh it backend, the query editor part. And even if you are doing the data refresh for complete data set semantic model, it has to recalculate each and every row by row, record by record. It has to get it read and try to project the output onto your front end part. That's how it works. Okay. New column. So 6 is the, if you're observing, calendar function. If you want to derive a new table by taking some specific column and a table level, like maybe the date related functions, or maybe if you want to derive a distinct information based on existing tables, in such kind of a scenario, we are going to make use of calculated tables. So it's going to act as like a bridge. Maybe if you're defining on a model related part, a bridge between one table connection to the another table, which acts like a bridge or intermediate tables too. Like example, if you're observing calendar auto, by supplying a parameter 6 for the quarter, the timestamp part, financial year part, or maybe calendar table, the calendar direct function wise, you can take the specific column, static column on an existing table. You can also derive a new table functionality by using this calculated table or new table functionality from a DAX object. Again, this is going to store on your data model and it showcase the table, complete table setup will be get it exist. And major thing, we will get a questions like, yes, I am deriving a calculated table. Can this will be visible to you at the Power Query editor? No. Okay. You are deriving by using Power BI desktop level, the existing field or complete table information. Table or column you are choosing. So that new tables will not be get it visible to you at the Power Query editor. You are not fetching the data from database. You are deriving some supplement or intermediate table at Power BI desktop level. You're doing some aggregations there and deriving some new table, custom table as per your modeling part, or maybe as per your building the one side to the many relationship part. You are deriving a new table or calculated table. Once you derived, the icon should be in the form of, the table icon should be in the form of a table with small calculator so that you can easily identify either it is a new table which you have fetched from the database, or is that a new table which you created, the custom table you created by taking the reference of existing fields. So like that, we can easily get to know which table it is. Okay. This is very, very important slide. You'll definitely get questions related to calculated column versus measure. What's the difference between calculated column and measure? If you're observing calculated column part left hand side, create values for each and every row wise. You can see just like a table level, one new column will be get it generated if you're working in a calculated column. Measures on demand you are creating by taking the reference of aggregations, or you're doing some summarizations, or maybe if you're calculating some time intelligence functions wise, you are deriving on demand, but it is not going to store on your data model. That is important. Anyway, I'm going to cover in the next point. And stores the value in PBX file, Power BI extension file, and measures calculated based on filter context, or maybe if you are trying to filter with the text or numbers or date related, okay, time intelligence functions, and make use of it. That's going to be a measure option only. Calculated column, increase the data modeling size because you are adding a new columns automatic, obviously, right? It will be increase the table size and as well as size of the PBX file too. And doesn't affect any of the data modeling part because the values itself, the output of the measures will be getting stored in the form of cache data, logs. And calculated column, row by row calculation, you can see by each and every row record by calculations, which will be definitely impacts on your performance. Measures, as I said, still optimal, but you can see some further data is some consumption is there, but not that much of row by row calculation and the impact. Must be referenced with measures and reuse it. We can reuse this, and always measures are reusable. We are already aware of it. Once you define the measure, we can reuse it instead of again redefining the measures on new calculations or some new DAX related functionalities. These are the major differences between calculated column and measures. We discussed about, we will also call this implicit measure and explicit measure. Like implicit measure means existing metric related information, we will call it as an implicit. Explicit measure means we like example, once you dragged and drop maybe existing column like a sales amount, you can see some number. Explicit measure, with the help of calculated measure, you are creating a explicit new measure. Okay, so which will mean not get stored on your data level. That is important there. So implicit and explicit we discussed. Creating the different types of DAX formulas like calculate function wise, filter, modify context we discussed. And what is the difference between the measure calculated column and calculated table? We discussed about it. Fine. Moving on to the next concept, design scalable semantic model. Scalability part. These are the important things that we have to keep in mind. When you are working on a data modeling designing part, what are the new changes that you are trying to accommodate, whether the data is growing and how we are going to handle the data growth. And you have to think about complexity as well. Whether you are managing more number of measures on a single model, how you're handling that in an ease. These things plays a major role while working on the semantic modeling part and as well as designing layer on the model view. Let's go into the deep. See here, this complete structure hope most of us know. If you're working on a Power BI related activities, we know something like import method is there when you're connecting to an on-premises or cloud databases, like import and direct query methods will be showcased once you supply the server details and so on. Other than that, if you are working on a cloud-based environment on an analytics front, software as a services, there is one more storage mode name called direct lake. Okay, we will discuss it. Okay. Import method stores data in Power BI and supports any kind of a data transformations and requires data refreshes. We will perform the data refreshes on demand. Okay, data refreshes on demand. We have to refresh it whenever the new stats or new numbers will be added to your extracted or connected tables. That's how it looks like. It's a kind of a copy to your application, Power BI level. You have to pull all the tables right to the layer, Power BI layer, and you have to all the transformations that will get supported, and you can perform manually or we can also automate it. Data refreshes. You require mandatorily you have to perform some scheduled refreshes or manually also you can refresh it. That's what the import method works. That's how it works. Direct query. So whenever if you're working in larger data models and if your data set sizes are very big, in such kind of a scenario, instead of importing all the data into this Power BI, right? You can connect the source, only stores the metadata inside the Power BI. Like it's not going to copy it, the complete table and all, everything, right? Just going to store the metadata into Power BI and you can automatically perform the data refreshes there. Automatic auto refresh option is there. We can enable that feature as well. But the thing is, it's having a limited data transformations. We will not perform as like import method. If you want to perform some cleansing operations on direct query, it will not get added to your advantage. You are doing some internal transformations inside, which is not allowed if you're using direct query. As I said, stay up to date with the source. The data refreshes part up to date. You don't need to do manually or automated wise refresh. Whenever the backend data, the connected table information is changing, automatically the front end or the connected Power BI application will be getting added with new results. That's how the direct query. When to choose? Whenever if you're working with a larger data set, in such kind of a scenarios, semantic model creation part, we will use this direct query. But limitation here, limited data transformations, most of the data transformation. So how can we handle this? In such kind of a scenario, you have to do most of the data transformation activities, the backend team itself, data engineering team, or maybe if you're already part of data engineering team, you have to ask them to add some new columns or do the changes on the data types and so on. This is how it works. Fine. Suppose if you're directly connecting and your application on the cloud part, Fabric Lakehouse part, you can connect directly to the Fabric Lakehouse. And it is here also, it is supported limited data transformations, cleansing operations. Stay up to date because already the data is visible on a one lake and you're just refreshing data directly. That's how it works. And the naming standard I mentioned it as a direct lake. So direct lake, which you are working in the cloud-based environment, software as a services, inside the lake house, you are creating a semantic model there. That's the reason we can, the faster community part, faster copy, because already data is visible to you on the one lake itself. So that's the reason it is more faster compared to the direct lake or import method, but limitations should be added. Okay. Please keep in mind how your model works and so on. It is, we have to decide as per the architecture. Okay. If you're combining few tables, like most of the time, what we will do in the sense, fact table, we will take it as a direct query because which is holding the huge data. Dimensional tables or categorical tables, we will use it as an import method. So that it's a combination of two storage methods, right? Import and direct query. So we will call it as a composite model define. Please keep in mind, we are discussing currently about import and direct query. And direct click is something which we are calling or creating a semantic model at the cloud front, okay, in Microsoft Fabric Cloud. Got it? Important. We will discuss some more details there. Best practices, if you are working on a data modeling part, so connect to the views instead of the tables. That is, most of us, we will do it same. Like instead of directly importing the tables, we will create on the top of the views, okay, with the same views, and we will connect over each and every table based on the relationship. And we will also perform incremental refresh and avoid unnecessary data or information instead of extracting huge data. Extract required columns, not all the columns. Suppose my table is holding with 100 columns, we will not import all 100 columns or perform all 100 columns level transformations. We will add few columns, whatever it is required, and remaining columns will definitely get it deleted, query edited part while doing the cleansing operations. Try to cross-verify while doing the data modeling that data types true. Which data type it is. If it is incorrect and you are trying to map, it's an abnormal results will be get it reflect. And try to check how the connection between one table to the another table. Is that the same or is that any differences between the column names? Just try to cross-verify. Ensure that query folding is happening or not. So this is very, very important. Query folding example, if you can ask me. You are doing some changes on the table level, which will not do the major, like we have to most of the time, because it's an upstreaming front, we have to do the cleansing operations as well as perform the result, complete result of your data transformation layer. So that it reduce the work, what you are doing at the front end level, Power BI desktop level, the engine prospect, and it will define accurate results so that you can find the same SQL query at the database front. Okay, like that, you have to define the query folding techniques as well at Power Query retail level when you're doing some set testing. These are the very important data modeling best practices while preparing for the upstream of your activities. As much as possible, we can push these activities to the upstream because downstream part make it as a lighter weight. Okay, that's how we will design. When you are comparing these workspaces, you can see most of us trees, a smaller semantic model storage format or larger semantic model storage format. So Power BI Fabric requires, Fabric layer requires, whenever if you are enabling or else working on a semantic model, we can enable these capacities. By default, it's added with a 10 GB limit, storage limit. And if you want to enhance or auto scale, we can also add this large semantic model storage format. We just have to enable from the administration portal itself, like when creating the workspaces. Okay. Two types, as I said, smaller semantic model storage format, larger semantic model as per your data set size, which is grow rigorously very faster. Such kind of a scenario, we have to make sure that this kind of an addition to your semantic model building at your cloud environment. Incremental refresh, most of us, whenever the data instead of refreshing the huge amount of information, we will perform this incremental refresh configurations too. At Power Query Editor level, we will define something like a parameters based on the date, range start, range end. After defining the parameters at Power Query Editor level, we can also work at the power configuration policies at the desktop. And how many years or configurations, like is that a monthly wise, you want to get it last month to the current date, or last quarter to the current date, you have to get it refreshed instead of refreshing the huge amount of information. So with the help of these parameters, we can define this control. Okay, partitions also we can define it. We can define this very bigger table to the smaller segment so that it is very easier to perform the data refreshes as well as on demand if you're performing some data movements from one to the another. Okay, these configurations, most of us we are aware, SSMS, SQL Server Management Studios or tablet data level also, we can configure these partitions. Currently, there are some charges. That's what I have observed in the tabular editor, but still I'm using some older versions, which is there in the ZHub when I'm doing the configurations of the partition layer for each and every table level, if it is very bigger in size. Okay. Example I just added here, like if you're observing data has to be archived instead of refreshing huge from 11 to 21. And remaining data is that a day wise I can use import with an incremental refresh, or maybe if you want to perform the data refreshes, right, as it is from the real time to the backend data to your application, like that we can configure with the direct query mechanisms. You can see the numbers, how it is getting changed, the differences. Okay. Green color is for the import method, all the data. And if you're implementing incremental refresh by using range, start, range, end parameters, parameter defines in the Power Query Editor after implementing the policies at desktop level, you can see the yellow color, right? Only the last quarter wise changes are real numbers on day-to-day basis, each and every timely basis. You can see direct query mechanism as well. This snapshot, most of us are aware of it. So how we are going to perform the manage aggregations and as well as where we are going to do these activities means we will do these activities at the modeling views, model tab. And you can find the table stats as well. Is that an import easily identified, okay, by using some layer and the ribbon level, you can see some dotted lines means that is going to be the direct link or direct query mode or complete extraction from the backend database to the Power BI. You can see an import kind of a layer as well, some complete blue color so that you can get to know which method, which storage mode we are using. Okay, you can also check the storage mode on your modeling view. And the storage method is that an import or direct query and so on. And one very important thing, okay, import method, once you import it, we don't have an option to change it to the some another storage method, like direct query is not possible to change it. Suppose you already extracted the data via direct query and we can change it. We can change it to the import method, that is possible. Hope. If you're not aware, we can change it to the all the table information extraction to the application as well. So vice versa is not possible. Direct query to import is possible. From import to direct query is not possible. We have to re-extract it one more time. Hope up to this part, do you have any queries? So I'm going with the flow. If you have any queries, please raise it before moving on to the semantic design. Any queries in chat? Kaudanya, any queries? Am I in mute?
Yeah, we have one question for Sabin. Okay, can you please explain the difference between sum and sum x?
Sum is the column level. Simple thing is, it's a column level function. Suppose if you want to iterate the complete table level, X table level function. So you can supply inside the table along with some another parameters to expression parameters too. That's how the major difference between sum and sum X. It's a individual column wise. If you want to preferably make use of X, I mean, without using the complete table, specifically one column, existing column in a table, number related, we can use a column directly. Or maybe complete table level if you want to add an inside any new parameters, if you want to get it derived in such kind of a scenario, table level function will be get it used. Okay. Fine. Moving on to the next. Apply star schema design. Most of the times, whenever we are working on a data modeling part, we will try to build a star schema. But here, if you're observing, whoever still not aware of these designing principles, if you're observing a table, fact resellers table in the center, which is maintaining the fact related stats like foreign keys. You can see some key kind of an icons, right? Some number related icons, product keys, order date keys, due date keys, ship date keys. So fact table, which is going to maintain the foreign keys plus important metrics or numbers. And such kind of fact table, we already discussed additive fact, semi-additive, non-additive. And that is a centrally located fact table, which is going to have a huge data, number related information. And remaining all are surrounded with the dimension tables like a sales, territory, product, date, resellers, employee. It is a lighter weight, okay? It's going to have a categorical information like categories, product categories, or times, date dimension is there, and product alternative keys, so reseller information and employee related stats, not a very important metrics, okay? That's going to hold by centrally located fact table, not by surrounded tables. Dimension table changes less frequently, as I mentioned in the left side. And if you're observing, each and every dimension table is directly pointing and connecting to the centrally located fact table. And if you're observing, this schema looks like a star. Each and every dimension table directly fetching and connecting to the based on identical keys, for product key to the product key. So dimension table is going to hold primary key, fact table is going to hold foreign key there. Okay, important. Suppose if you have some hierarchy, like example, product table is having some product category, product subcategory, which is not linking to the fact resellers table. It's having some distribution, okay, subcategories or hierarchy. Such kind of a model, we will call it as a snowflake schema. Okay. So as per the performance optimizations part or flexibility of usaging of each and every table connectivity mode, best or suggestible approaches, we will try to build the star schema. If not, we will go with another type of a schema, that is snowflake schema as well. Okay. This is how the model looks like. If you are observing category product table, and it is connecting one side. As I said, product table is holding the one. That means primary key, and the star stands for many. Maybe there are some repetition based on similar column. Likewise, another year to the sales, which is having one side. One is on unique information, which we are maintaining on the year side. Sales table, many, star stands for many. Okay, data repetition is there based on the connected column. This is how the sales, the relationship between table to the table, sales to the ER, sales to the product. Whenever if you are trying to set up a relationship on the data modeling part, model view, these are the types of cardinalities: one to many or many to one, vice versa. Most of the times the data will be get flowed from one side to the many side. You can see here, right side. The data we can get it filtered from product table to the sales table as per the arrow mark. Okay, from category column, I can filter the sales table, but not sales table to the product table. Please keep in mind that is important. One to one, which is unique information of one instance of the table to the another table, unique instance of another table. Many to many, we have to avoidable this type of a relationship, which is going to have the duplicacy between both of the sides, table one or table two or table two to the table one. Just to make sure that in such kind of a scenarios only, we will build some bridge tables by using calculated table mechanism. Got it? Important, please keep in mind. This is how we are going to set up the relationship, cardinalities, one to many Four types: one to many, many to one, many to many. Important DAX relationship functions: related table, user relationship function. So as I said, right, data flow direction, smart, one side to the many. Sometimes we will use the cross filter function also to get it, to bring the good performance while execution of our reports. Cross filter functions, there is a separate functions to change the direction. If you want to bring the data from both of the tables, we will use the cross filter functions. Combines value, treat as, parent-child function, and hierarchical path functions are there for row-level security for hierarchical design approaches. Okay, so these are the very regular used functions whenever if you are trying to build some new tables or picking up from new columns from one table to the another based on the connections between two tables. And user relationship function, most of us, we are aware of it, like we were not known of user relationship function. If you want to, between two tables, we are going to build one relationship. If you want to add, or else if you want to bring few more analysis based on another table, in such kind of a scenario, you're going to use user relationship functions. Like this. There are one connection is there, active connection, solid line, and dotted line stands for inactive relationship based on shipping date wise date. If you want to see that analysis as well, in such kind of a scenario, you're going to use user relationship function. Okay. This is how the data looks like based on sales wise order date. Suppose if you want to see the analysis based on ship date wise orders, sales order, this is how it looks like, ship date wise sales information. So here we are using on the calculate part and filter context level, user relationship function, calendar table, date column, ship date, ship date column from sales table. Okay. So please keep in mind, between two tables, you will maintain one active relationship. If you want to see an analysis based on shipping date wise sales, you have to make use of a DAX related function, user relationship function there, and a filter context mode, and call that columns. Okay, you have to bring the relationship, inactive relationship, and you have to specify the columns as well. Date table, date column, comma, sales table, ship date column. You can see the difference between order date wise, what's the sales, ship date wise, total sales. Fine. Few DAX related functions they have added related to the time intelligence functions, parallel period, right? Same period last year. Or maybe if you want to add date add functions, this is some examples they have added. So this is how iterative function works. You can see this. Just now somebody asked a question, some X on a table level, and you can call these two columns as well, sales quantity into sales. Okay, one more extension as an expression, sales table minus sales column, sales table minus cost column sales. Like this it works. Okay. So if you're working on a larger data models, try to avoid iterated functions. That's what my assertion. If you are using the direct functions like sum, it's a good advantage as per the performance prospect. If you are working on a larger data models and using the iterated functions like a sum x, average x, count x, or max x, right, min x, and so on, definitely impacts the performance. Okay, it works on a complete table level, row by row only it's going to calculate, but try to avoid if you're working on a bigger data sets. One more example related to the table level functions. And Windows function when to use means if you're working on a running totals or rankings, in such kind of a scenario, you're going to use Windows function. Okay, you can see one example they have added like offset, index. Okay, index, offset, these are all comes under Windows functioning format only. So between previous year's sales and sum of sales, you can see the values and then offset method with -1. If you want to find out ranks also, we can add ranking functions too. And few information functions like has on value, treat as, these are all comes under information functions. Has on value of this particular product, if condition only, it's a logic, okay, conditional statement. Sum of sales value. So in such kind of a scenario, you can see the result without You can see output, total sales for single category. Okay. Make sure that lot of DAX functions are there. So just very important, please go through it, like a treat as it comes, has on values and so on. Very interesting concept it is, calculation group. Suppose instead of deriving example, I have derived a few of the measures like a total sales, okay, average cost, and try to pick one more, shipping cost. I have three already derived. I want to specifically define a time intelligence functions for few of the calculations like year to date wise, quarter to date, month to date. So three already existed. Again, if you want to calculate time intelligence wise calculation, we have to 3 into 3. Again, one more I have to define, right? More number of calculations I have to get it derived. If you want to define with the time intelligence wise calculations. To get rid of new calculations, okay, we have a specific module name called calculation group. We can reuse it. So recently I have given a presentation related to the calculation group. We can reuse the existing measure and we can supplement whatever the logic we are expecting in the form of selected measure here. You can see year to date, selected measure, dates YTD. So all the supplements will be getting added in the calculated item category. Whenever, if you simply add drag and drop onto the matrix visualization, this particular calculation group, automatically you can utilize in the form of either in the calculating group wise mechanism calculated item, or you can also define this logics and a field parameter concept as well. So dynamically, if you want to slice and dice based on some categories. Got it? This is how it looks like if you're observing year to date, quarter to date, month to date analysis, along with slicing and dicing conditions wise, we can implement of field parameter logics too. Okay. So in this session, we discussed about storage methods, modules that we have, relationships, types of relationships, and how the data is getting filtered and between two tables or column-wise information are also important, readability format-wise. So most of the times, if you're trying to define logics, try to make sure that you are going to use the variable concepts also, okay, which is as per the performance readability part, which is very good and as well as efficient. And dynamic calculations we discussed along with text functions and time intelligence functions and so on. Last concept here. Am I in time or few or 2 or 3 slides? Are we good?
Yeah, we are good,
Counting it.
Rajan. Yeah, we are
2
good.
slides
Babu
only.
also
We
joined.
almost completed. Babu joined. Okay.
Okay.
2 more slides. After that, hand it over to Babu. Few important things that you have to keep in mind while working on the Power BI as a part of a solution: data source, modeling, visualization, and then environment choosing functionalities. So try to check within the Power BI itself. Make sure that we have an option optimize tab is there at the remote level. Try to check the performance and record it. Okay. Just try to cross verify whether the DAX level issues or performance it is consuming more on the milliseconds wise, or maybe if you're deriving some custom visuals part too, which one it is taking more time so that it reports the logs. You can check it and decide which one. So if it is really impacting and it's a bottleneck for your refresh runtimes, just try to check the logic, okay, how it has been implemented. And even you can make use of some external tools for this as well, Tableau Editor, DAX Studios, so that you can optimize there and make sure that change the logic as per the requirement. So this is how DAX query, how much time it has been taking after filter and key filter function. Same logic, same output. You can see the difference between by using a direct filter function on a calculate expression with filter and same key filter based on particular specifically order quantity wise you are defining with a file. So you can see the output, okay, milliseconds file 2754 to 54 has been get reduced. So change the logic. So for that, you can also take the support from AI tools like you can use it, and Tableau Editor, DAX Studios also will be helpful. And even there is other tools like a measure killer, which is some paid versions are there. But preferably, we can make use of free tools like further also free versions are there. Make use of it. Fine. That's the discussion about DAX related and as well as the semantic model in Microsoft Fabric related topics. And as another speaker already there, so I'm stopping up to this part. If you still have any questions and maybe if you want to discuss something, I'm covering this topic as a part of my speaker. Okay, he's went urgency, so he's not able to join. So I'm covering this topic. Any questions, you can always reach out to me via LinkedIn. Okay, and I'm happy to help you. I'm stopping.
Yeah, thank you, Rajendra, for a quick jump in and providing a valuable session on semantic models. I think so far we have covered in the DP600 for Microsoft Fabric